So in this video, we're going to discuss lesson number 5.5, which deals with parallel perpendicular lines, and we're going to talk about how to write equations of them. So the first thing we're going to do is take a look at the relationship between slopes for parallel lines. So this is from your textbook, and this is something that you're going to see in geometry, and you need to know that if two lines have the same slope, then they are parallel. And it also works backwards, where if they are parallel, then they must have the same slope. So the key thing that I need you guys to understand is that two parallel lines have the same slope. So you would be using the same exact slope. Okay. So, when you read an example, right? So this is skill number 19. We are going to be finding an equation of a parallel line given an equation in slope-intercept form and a point. When you start reading the example, as soon as you see the word parallel, I want you to, right above it, write down that you are going to have the same slope. It's going to be very helpful to you. Okay? So we're going to write an equation of a line passing through -3, -5 that is parallel to y equals 3x minus 1. Okay. So if I have the same slope, I'm going to look at this equation and I'm going to find the slope in the equation. So remember, this is in mx plus b form, so this little 3 is the slope that we're interested in. And that's the only thing you're interested in. So what I'm going to do here is I'm going to write down that based on this information, the slope of my parallel line, and notice me using this little symbol here, I want you to use this as well, is actually 3. And the point that you need to use is -3, -5. Now here's the thing. If you read the equation, the directions, it says write an equation of the line. It doesn't specify which form you should be using. So I want you to use the form that is easiest for this example. So if you have a slope and a point, I want you to use point-slope form. So just a reminder, the point-slope form looks like this. And what I'm going to do is just replace the values. So if my y here is -5, I'm going to be adding a 5. Remember, it's opposite. My slope is 3. My x is -3, so it's going to be minus -3. And that's it. That's your answer. So if I don't specify which form, I want you to use the easiest one for yourself. However, if I did ask you for slope-intercept form, then I would want you to rearrange this or find the b, whichever one is easier for you. Okay? So now what I need you to do is pause the video and try this example and see if you can get the right answer. Good luck. Okay, so now that we talked about parallel lines, it's time to talk about perpendicular lines. And this is a little trickier. But perpendicular lines are two lines that intersect to form right angles. So these two perpendicular, so all of these angles are going to be 90 degrees. Right, so this is 90, 90, 90, 90. So that's a definition from geometry. Something interesting to note is that if you have a horizontal line and a vertical line, and I know mine is not too vertical, but a true vertical line will be perpendicular to a horizontal line. So that's going to be come in handy in the next couple of examples. Okay, so what we're doing here is you actually have a picture already where you have two lines that are perpendicular, and I'm going to erase my 90 degrees here so we can clearly see the slope. Okay, so you had the slope here of this line, right? Remember, it was -3 over 2. And now the slope is positive 2 over 3. So now notice there's a couple things. It used to be negative, and now it's a positive, so that's going to be opposite. And my fraction switched, so, or it's called the reciprocal. So when your numerator goes in the denominator, so it goes to the bottom, and the denominator goes to the numerator, that's a reciprocal. So opposite reciprocal. I believe I spelled it correctly. Okay, so two perpendicular lines, and this is our next slide. two non-vertical lines, if their slopes are negative reciprocals, then the lines are perpendicular. So again, negative reciprocals, or another word, instead of negative you can think of opposite, and perpendicular. And it also works backwards, where if two lines are perpendicular, then their slopes are negative reciprocals. And I just want to take a minute and talk about negative reciprocals. So I'm going to give you some slopes, and I want you to write down what you think the opposite reciprocal would be. So I'm almost done here. Okay, so what I want you to do is think about what would be the slope of perpendicular lines, so using each slope. And it might be useful to pause the video and write this down on your piece of paper, and then continue playing it to see if you got it correct. Okay, so opposite, I'm going to take care of that first. So if I had a positive slope, now I'm going to have a negative slope, and it has to be reciprocal. So instead of 2/3, 3 will go on the top and 2 will go on the bottom. So this is my opposite reciprocal. For this one, it used to be negative, now it's going to be positive. I don't need to write down the plus sign, but I need the reciprocal. It's a little tricky here because you don't have a fraction, so we're going to make a fraction. So -3 is really -3/1. So my reciprocal of 3/1 is going to be 1/3. So my 1 now goes to the top and my 3 goes to the bottom. Remember, we switch them. Okay? So for the last one, I had a negative slope, so now my slope is going to be positive. I don't need the plus sign. However, I do need to do the reciprocal. So it's going to be a fraction, and instead of 1/4, it will be 4/1. So make sure that you can find opposite reciprocals in order to find equations of perpendicular lines. Okay, so skill number 20 in this section is going to be determining which lines are parallel and perpendicular just based on slopes. So what I need you to do is determine the slope for each of the equation, okay, for each line. So here it's already in mx plus b form, so this is the slope here. So this slope is, the slope of line A is 5, and this little a helps me be organized. Now over here is in standard form, so what I'm going to do is I'm going to rearrange it. I'm going to subtract x. And if I'm interested in slope-intercept form is probably going to be the most useful one. And I want to get y by itself, so I'm going to divide everything by 5. And I get y equals -1/5x plus 2/5. So this slope here of line B is -1/5. And then my last one also needs to be rearranged. So -10y is equal to 2x, right? I'm going to add 2x to both sides here. Remember in slope-intercept form, your goal is to get y by itself. So everything that we're doing is helping us getting closer to this to that form by moving things that surround the y. So first we added the 2x. Now we have this -10, so we're going to divide both sides by -10. And I get y is equal to -1/5x. And how did I get this -1/5? Well, I simply reduced, right? So we have 2/10. They both can be divided by 2, and they become -1/5. So our slope for line C is -1/5. Okay, so if any. Okay, so let's start with parallel. So which lines are parallel? And I'm going to write my little parallel symbol here. So parallel lines should have the same slopes. The two lines that have the same slopes are line B and line C. Okay, so line B and C. Perpendicular, they have to be opposite reciprocals. So line A and line B will be perpendicular. So that pair. And remember, for perpendicular, it has to be a pair of lines. So A and B, and also A and C, because A has a slope of 5 and C has a slope of -1/5. So it's going to be another pair. So line A is perpendicular to line C. Alright, so this is my answer here. And again, remember, if I'm asking you to determine whether lines are parallel or perpendicular, you are looking at slope. You're not interested in anything else but slope. Okay, so now it's your turn. Your job is to determine out of these three given lines which ones are parallel or perpendicular. Okay, so this is still skill number 20 because it still has to do with using slopes of finding lines and determining whether they're perpendicular. So here, I'm only interested in perpendicular. So I want to find the two slopes and decide whether they are opposite reciprocals or not. So it's almost in slope-intercept form. I need y to be by itself. So what I'm going to do here is I'm going to rewrite it first so it's easier for you guys to see. And then I'm going to divide everything by 12. And I get y is equal to negative 7 over 12x plus something, right? Technically speaking, I should simplify this, and I will. But if you guys think about this, you're just interested in slope, and I can actually simplify this even more. But I'm only interested in slope, so honestly, I don't even care what that y-intercept is. I just want to know this. So that's my slope here. And then I also need to know the slope of my second equation. So I'm going to take my line B here and get the y by itself as well to get the slope. Okay, so it's 11y, so I need to divide by 11. And I get y is equal to 16 over 11x. And hopefully you guys could see that even though it appears sort of on this picture that they're perpendicular, they're actually not perpendicular because the slopes are not opposite reciprocals. So no is the answer. If I ask to justify your answer, you would tell me that the slopes are not opposite reciprocals, and that is why these two lines are not perpendicular. Okay, so again, very similar to the previous you-try example, but I'm specifically asking you, are these two lines perpendicular? And notice that you are asked to justify your answer using slopes. Now, on the quiz, I will not tell you to use slopes. I'm just going to tell you to justify your answer, and I would expect you to realize that slope is the way to go, that you should be using slope to decide whether they are perpendicular or not. I don't think I'm going to actually tell you that. Okay, so try this one and see if they are perpendicular or not. Okay, so this is our last example in this section, and we are going to be finding an equation of a perpendicular line given an equation in slope-intercept form and a point. So, when you read an example and you see a perpendicular, what I want you to write, again, very similar to the parallel, I want you to write what does that mean for the slope. So as soon as you read perpendicular, I want you to write opposite reciprocals. Okay, so I am not using 2 as the slope. This slope is 2, but I'm interested in slope of a perpendicular line. So I need to find an opposite reciprocal. So I'm going to make a little fraction. So this slope was positive 2, so my slope is going to be negative, and I need to do the reciprocal. So instead of 2 over 1, it will be 1 over 2. And this is the slope that I'm interested in. I want to know, use the perpendicular one. And it does have to go through 4, negative 5, so I'm going to use this point. Again, notice it doesn't say what kind of equation, so what form. So if I have a point and a slope, point-slope form is the easiest form. So I'm just going to use that. So it will be y plus 5 is equal to negative 1 over 2 times x plus, just kidding, 4 is positive, so it will be x minus 4. And you're done. That's it. If I ask you for standard form, you'd have to do a little bit of rearranging. If I ask you for a slope-intercept form, you'd have to rearrange it. But if I don't specify the form, do what's easiest for you and don't waste your time. Okay? I do want to take a second and just show you really quickly how to check your answer if you have some extra time. And you can actually do this here because it will work out because you're using this point. So never mind. Okay, so this is your last try example for this section. So do your best and hopefully this comes out to be correct.